Hello students, welcome once again to Dr. Soros's classes. We are back again with the group theory videos, right? We were doing the videos on group theory, okay, and we have covered multiple topics, We have covered multiple topics on group theory. Now, the last topic that we were speaking about on group theory was Euler's phi function, right? And I gave you multiple examples on that Euler's phi function, like how would you find the number of cyclic groups of order 1, like number of cyclic groups of order say 2, which is equal to phi 2 by phi 2, which is equal to 1. So something like that, okay, where Euler's phi function was given as phi n is equal to k belonging to natural number, and what was it, 1 less than equal to k, which is less than equal to n, okay, and k comma n is equal to 1. Okay, today we are going to talk about the center of a group. Okay, so let's rub all this off. Today we are going to talk about the center of a group. Okay, now if you can see below, the definition is clearly given to us. The center of a group. What is the center of a group? The center of a group is defined as ZG. What is ZG? Why does this happen? What is ZG? The ZG is called a center of the group. It's when it's equal to G belonging to G, some G belonging to the group G, okay, such that Gx is equal to Xg, and X also belongs to the group. G. Understood? So what is the center of the group, students? The center of the group is a set such that Zg is denoted by Zg. Zg is the center of the group, such that G belonging to the group G, Gx is equal to Xg for all x belonging to G. Okay, so that is the basic definition of the center of a group. Now, if I am to give you a small example on this, okay, so if I am to give you an example, let's show you in some set format. Let's say if I have a box, right, set format like this, okay, and this is the group G, and suppose I have Zg inside, something like this, Zg. So if we can take any G, okay, and any X, and then we multiply, like G into X, and then we do X into G, and we get G into X is equal to X into G, okay, such that for all X comma G belonging to the group G, then if this is inside this Zg, then Zg is called the center of the group. Okay, then this Zg is the center. Okay, you see, when we go on to the mathematics part, right, then we will be going ahead and doing sums on this, mathematics on this, so that way your doubts, any doubts that you have, mathematical doubts, will be clear. What we are doing as of now is theory. Okay, So we need to understand and concentrate on the theory part, because if we don't understand and concentrate on the theory part, the mathematics will be absolutely difficult. You won't be able to make head or tail out of it, and you won't be able to understand what's going on. Okay, so concentrate on the theory, because the theory is absolutely important. You see, sometimes it feels like in mathematics everything has to be mathematics. That's right, everything has to be mathematics. But what happens is, these people, when they started doing things with sets, when they started taking sets and they started taking numbers, say 2, 4, 6, 8, they started finding patterns. Mathematicians started finding patterns. When they started finding patterns, they found they could find different things, subgroups, center of groups, like we are learning right now, abelian groups, okay, simple groups, cyclic groups, okay, non-cyclic groups, group generators. So they found that they can find many things with these numbers. So they went ahead and they kept on writing all this. So that's how this became group theory, and it was converted to modern algebra. So I hope the concept of center of group is now clear to you, where how do you get the center of group when G will belong to G, Gx will be equal to Xg for all x belonging to G. Now we will go ahead to the next slide, and now we are going to understand about some results on center of the group. Okay, let's put another color. Some results on center of group. What are the results? What are the important points actually? First one, the center of group Zg is always a normal subgroup of G. So what does that mean? It means that Zg, the center of the group Zg, will always be a normal subgroup of G. Okay, students. Now, what is the normal subgroup? Yeah, of course you know that HA is equal to AH for all A belonging to G. Okay, so you know that is the definition of a normal subgroup. Normal SG I'm writing, normal subgroup, and of course this H is equal to, okay. Next one is the order of G is equal to P to the power n. That P over there is indicating prime number, okay. The P over here is indicating prime number. It's written there also, okay. So the order of G, if the order of G, let the order of G be P to the power n, okay. So order of G is equals to prime number to the power n. Then the order of Zg is greater than 1. So now then the order of Zg is greater than 1, where P is a prime number. What are they trying to say? They are telling you to assume that the order of G is equal to any prime number to the power n. Okay, I hope you are understanding what I am saying. Order of G means order of the group. Order of the group is any prime number to the power n. So if I am to assume, say, order of G is equal to, say, 7 to the power 3. Okay, I'm just assuming 7 to the power 3. Then the order of Zg will be greater than 1. The order of Zg, integers of the group, will be greater than 1, where P is a prime number. Next one looks very confusing, but that's not confusing at all. Okay, that's the integer of the integers of the integers of the integers of the group will be actually just Zg. Very simple actually, okay, but equally important. Simple but important. Okay, so Zg will be equal to just Zg. Alright, so let's move on to the next one. If G divided by ZG, Z is the integers, okay? I hope you know that one. Z is the integers. Actually, that's how you write the Z, okay? You need a double line over there in the middle, okay? But you don't have to write like that. You don't have to be accurate, okay? You can just write a Z, capital Z. So if capital Z, capital Z, anything you like to say, G divided by ZG is cyclic, the G is abelian. Then G is abelian. Then G is abelian. Okay, so what does it mean? If Z by, sorry, not Z, it means that if G by, so let's rub that off. It means if G by ZG is cyclic. What does that mean? Cyclic means there is a generator, right, that is generating. We have a generator. We have a generator, say A, that is generating this G by ZG. G by ZG will be cyclic. Then what they are saying, then of course G has to be abelian. G has to follow commutative property. G has to follow the commutative property. Did you understand? Okay. Next part is point number 5. It says G, if G is abelian, G is abelian, G is abelian if and only if ZG is equal to actually G. If the integers of the group is equal to the, so the G set is going to be abelian, okay, if and only if the integers in the group ZG, okay, will be equal to the group. Alright, so students, today we learnt about what? We learnt about center of the group, okay. With a definition, we learnt about center of the group. With its definition, I showed you how in set form you can get the center of a group. So in this center of a group, there are some results on the center of a group that we spoke about, right? The center of a group ZG is always a normal subgroup of G. Then if order of G is a prime number to the power n, and the order of ZG, the integers of G, will be greater than 1. Okay, then this one is another important one. ZZZG will be equal to only ZG. Next one, if G by ZG is cyclic, then G is abelian, okay, and if G is abelian if and only if ZG belongs to your G. Alright students, okay, so students, in this today's part we completed these two. I would request you to go through this video on center of a group, because you will be getting quite a lot of questions on this to find the center of a group. I have seen quite a lot of questions, not quite a lot, but very vital questions in the exams coming regarding the center of a group. Okay, so I expect you to be prepared, and even Euler's 5 function, go through it. That's very important part of group theory. So go through that and go through the center of the groups, and also please go ahead and watch the videos of the previous parts of group theory, so that you understand everything better and there is no mistake. Okay, and we will be continuing this in the next video. So for now, you keep taking as much help as possible, because all the help that you will be needing will be provided here at Solve Classes. Thank you for watching, students. We'll see you in the next video. Bye bye.